Individuals and interactions over processes and tools. What's this really about? What this is really about is a talk on agile thinking, agile processes, agile teams, why they work, why they don't. Because this line is one of the most overlooked lines, along with the other three lines, in the Agile Manifesto, which I'll mention. People tend to kind of, their eyes glaze off the Agile Manifesto with familiarity. I would like to draw your attention back to them and actually look at what was really being said. Something actually important was being said in this statement, and it's something that we've forgotten. And also with many failed Agile adoptions, and a remarkable number of successful ones, what we see is people often overlook this bit. The process, ultimately, it comes down to the people. Well, actually, somebody asked me downstairs, what's the one-sentence summary of your talk, Kevlin? And I said, okay, I can do even better than that. I can even skip the verbs. People. I've got punctuation in there is a comma, but that's what it's about. So, a bit about me. Normally, I'm not associated with the fluffy stuff. I normally tend to focus on software architecture, coding techniques, things like that. But I got myself involved in a lot of stuff to do with process, because half the time that seems to be where the problem is. If you actually look at even something as simple as coding guidelines, those are actually based on the idea of social negotiation. That's what coding guidelines are about. Occasionally they're about something technical, but most of the time they're actually about how people get along. That's why you adopt coding guidelines. If you wrote for yourself, you probably wouldn't care about coding guidelines, for example. But when you're writing a team, you're writing people you're never going to meet, and you're going to be the recipient of code that written by somebody you've never met. Suddenly this stuff starts mattering. So it does actually come down to certainly the people side of things. There's also the aspect of when people talk about things like requirements. Many occasions I've been in this situation, speaking to people, and I'll ask a really challenging question. What's the requirement for this? Turns out that that's one of the hardest questions to answer. It's quite tricky. And in many cases we find that actually the issue is not a technical one, but it's actually a people one, people interaction. So that's why I got into this side of things. I guess there is a relationship to my other interests, patterns and general programming stuff. But let's move on to this. This is a fairly familiar site with any luck. Manifesto for Agile Software Development. The context of it, 12 years ago. No, you see, you don't miswrite checks anymore. You just misremember the year. 13 years ago. That's 2001. This was written. 17 people got together, 17 people with particular egos, and they were trying to find common ground. Common ground in a reaction to what felt to be a number of heavyweight processes that have been growing in the 1990s. At the back end of the 90s, we saw a shift, an emergence, and there was a bit of a rupture in some quarters. Extreme programming was the name of the thing. It was a very polarizing term, and polarizing in the sense that either people really loved the idea or they really hated the idea. Very few people actually looked at the idea. Most people, it's a bit like politics. Most people form their opinions without actually bothering to look at the details. And so you'd say, okay, we're going to look into extreme programming, and some people go, yeah, and other people go, oh, yeah, I do XP. Oh, you do XP, that's really cool. So tell me about your team structure. Well, there's only me. Okay, so the pair programming's out. And tell me other XP practices that you're doing. Well, I don't comment my code. I was like, well, that's actually not an XP practice. It's an effect, not a cause. So you had a lot of that, and then you also had other people who dislike the language extremity, because when you think extreme programming, you think extreme sports. Extreme sports. Now, if somebody wanted to associate your software development project with an extreme sport, you're sitting there going, why on earth would I want to increase the risk of software development? The whole point of extreme sports is that they are about risk-taking. You expose yourself to risk, you get a real rush out of it. The last thing an organization wants is the language of risk increase. Yeah, we're going to do this in an extreme style. We're going to jump out of an airplane, we're going to code, and then we're going to pull the chute when it compiles. Okay, then we're going to ski down the mountain as it continuously integrates. Okay? We don't want that language. So you had this kind of thing going to and fro, and as people noticed the language of extremity, if you like, other people started looking, and they noticed that a number of these little processes have been around for a number of years, many years in fact. Starting from the early 1990s, they just had not really hit the mainstream. 1990s was kind of a sort of adolescent phase for a lot of software development. And it hadn't really sorted itself out. And there was this observation that perhaps some of these processes were too heavyweight, therefore what was needed was lightweight processes. There is a big problem with the word lightweight though. If you describe this stuff as lightweight, it sounds insubstantial. When you call somebody a lightweight, you're not paying them a compliment. So it is an ambiguous term in English. Anyway, there are all of these things. A lot of people got together and said, okay, look, what do we do? So the Scrum people, the DSDN people, and so on, all got together and they hung out and they just sort of for 3 days, and they found that because of their enormous egos, they struggled to find any kind of agreement. But the solution to most software development problems is to be found in the whiteboard. Yeah, one of the most powerful tools ever invented, and there it is in the background. Martin Fowler takes to the whiteboard and says, right, here we go, that's the first line. And I got everybody focusing on this stuff. We are uncovering better ways of developing software by doing it and helping others do it. First thing to notice is this is written in the continuous present tense, which means we're not done. It's a minor linguistic point, but it is an important linguistic point. It is not written in the sense of we have uncovered, or we uncover. It is we are uncovering. So it's a continuous process. Through this work we have come to value individuals and interactions over processes and tools. That's the one we will emphasize. Working software over comprehensive documentation. We'll come back to that one. Customer collaboration over contract negotiation. I won't really spend a lot of time on this because it'll kind of be obvious. It's all about the people. Responding to change over following a plan. That one I'm not going to emphasize so much in this particular talk at all, because it's really more the feasibility and the people. So this is the one we want to emphasize. Now, around this time, once they coined this phrase, agile, the agile phraseology started passing into common use. And perhaps one of the most successful approaches to take advantage of this was Scrum. Now, Scrum has been around for a very long time. Scrum has been around for over 20 years. It has changed its form in many ways. There are features of it that have been added and it's evolved. But also it has become associated with a certain orthodoxy, which is ironic when we actually will look a little bit at its past. There's a sort of a language and structure that's associated with it. So around 2003, really, onwards, Scrum started becoming the normal thing. Scrum is much more approachable linguistically, okay, as is the word agile. If you want to say we're going to do an extreme process, you want to sell that to somebody, that's not going to work. If you want to say we're going to use some kind of sports metaphor, it turns out that upper management loves this stuff. Okay, they're absolute suckers for it. So just in case there are any budding methodology engineers in the crowd who's sitting there thinking, oh, what should we call it? Shall we call it, base jumping, or shall we call it cricket? Then cricket's probably going to be more successful. Okay, just a clue. Now there is an interesting thing. Scrum is supposed to be very, very light in touch. There's not a lot you can say about it because it doesn't prescribe an awful lot. And yet there is a certification program. This observation is made by Mike Colmeyer. Scrum can't have its cake and eat it too. It can't be a simple framework that is not prescriptive and then start certifying people on how to do all this stuff. When you certify somebody, you certify them against a verifiable body of knowledge. Scrum does not have this, and its intention and its original design that it does not have this. So we have this kind of contradiction. How do we make sense of this? How can we be prescriptive and yet still this kind of much softer approach? So there's a contradiction that lies in the heart of the modern Scrum industry, but not actually in classic Scrum. So let's go back in time and actually really try and explore what's going on here and understand a little bit about the people side of stuff. Or, the complexity of software before we look at some of the people stuff. The defined process control model requires that every piece of work be completely understood. Given a well-defined set of inputs, the outputs are generated, the same outputs are generated every time. Now, this is taken from Ken Schwaber's book, Ken Schwaber and Mike Beadle's book, which is just over 10 years old, and was in fact one of the first books to actually bother with the word agile in its title. Agile development, software development, Scrum. And Ken Schwaber makes this important point about process characteristics. There are a number of different kinds of process. A defined process is one in which you can actually define everything. You can define the steps that are necessary. You can define the duration. You can define the materials, the scope of work. You can define the detail and know with some certainty. In other words, it's highly predictive and is well suited to well understood pieces of work. Now, we might think that software development is well understood at one level. Certainly our tooling is fairly well understood. The general gist of things is very well understood. The problem is, it's the detail that bites. If you actually write out, if you were to, for example, if you were to specify in detail what a software system did, what would you have in your hands? If you could specify in sufficient detail that you would know exactly what it did, what do we call that? Code, yes. So the idea of we're going to specify this, and we're going to come up with a spec in order to determine and estimate reasonably is a little fantasy. You can do it at the end. What you have is, somebody once made the observation about poetry. If you can describe poetry to the level of detail that you can precisely communicate to somebody the feeling of it, then what you have done is written a poem. Yeah? And it's exactly the same with code. Once you have got the fidelity of the detail, that is called code. It is a codified detail form, which is unfortunate because that's not what people want to estimate against at the end. How long did that project take you? Well, elapsed time was this. Yeah? That's how long it took. That's the only number we can actually offer you. But all is not lost. There is another family of process control models. Empirical process control models, on the other hand, expect the unexpected. I don't think Ken Schwaber is actually a Monty Python fan, because there's a sort of a slight sense of Spanish Inquisition here. It would make me happier if I knew that deep down he was a Monty Python fan, but actually I don't think he is. He's a bit straight-laced for that. Or he hides it very well. So, it provides an exercise of control through frequent inspection and adaptation for processes that are imperfectly defined, generate unpredictable and unrepeatable results. Now, the problem is that a lot of people look at these two definitions and they think, I prefer the first one, as if they had a choice. It's not a choice. It's a bit like saying, well, tomorrow's weather is going to be sunny, reasonable temperatures, no rain. Or tomorrow's weather is going to be wet and miserable and windy. Oh, I think I prefer the second one. No, you don't get a choice in it. It's going to be whatever it is. And it turns out that most software development looks like this and not the one before. Now, it turns out empirical process control models are nothing to do with software originally. Does anybody know the domain which they've been most, well, prior to software development, most thoroughly explored? Chemical process engineering. Now, the problem is chemical process engineering is not one of those things that people generally talk about. When people use metaphors for software development, they typically use things like bridge building, yeah, and physical construction, and various mechanical engineering domains, structural engineering, occasionally electrical engineering, but not so much. That's getting a little bit abstract. So normally people stick to the civil engineering domain for a very simple reason. Everybody knows what a bridge looks like. They have familiarity with it, and therefore they think they understand the domain, and they will work with that, and it acts as an appropriate style of metaphor, or appropriate style of communication. A metaphor is only successful if the other person understands the idea. If you're trying to use a known concept to explain an unknown concept, it doesn't work if the first thing is unknown. Here, I'm going to take an idea you're unfamiliar with, explain that, and then use it to explain another idea you're unfamiliar with. What? So, I'm going to explain chemical process engineering to you, which you don't know about, and you have no opinion on, as opposed to bridge building. You've seen bridges, you've seen them being built, you understand that, you occasionally get reports of bridges doing crazy things, that wobbles, or that overran in terms of its pricing. You have an intimate relationship with the concept of bridges since you were a child. Chemical process engineering, not so much. So the thing is, I'd explain something you didn't know to explain something else that was mysterious. Software development, that's not going to work. That's why we don't use chemical process engineering metaphors. It's why I don't talk to my mother in chemical process engineering metaphors. She says, what exactly is it that you do, Kevlin? That's one of those, if I told her, you know, it wouldn't help. So the point here is that we already have a domain. Now, this is a very meta-level approach. What we're defining here, if we talk about empirical, based on concern with verifiable by observation or experience rather than theory or pure logic. I want to be precise, idealization. Pertaining to or derived from experience, capable of being verified or disproved by observation or experiment, which is another important point. It's the idea of verification, hypothesis forming. And this is an area again that is massively overlooked when we think about how people interoperate at the level of something like a sprint. Their interpretation of a sprint. Why is a sprint called a sprint? More infatuation with sports metaphors, but why is it called a sprint? Why is it not called an iteration? Because it is an iteration. Why did they choose to call it a sprint?
Short.
It's
short.
It sounds short. Ah, yes, shorter than what? Huh? The marathon. Yeah, okay. So there's something there, but it's actually that you're kind of in the right place. It's shorter than something, and the question is, what is that something? It's shorter than an iteration, or it was. In other words, in the perceived popular mind, what an iteration was 20, 25 years ago was something quite different. We are stuck with language that is reminiscent of the times. So, if you delete something, if you're working with Windows, if you delete a file, where does it go? Recycling bin. If you use a Mac, where does it go? Trash can. Why the difference?
No recycling in 1980 or whatever it was.
Yes, exactly. The difference is it captures, it's a snapshot of the time. Okay? Trash cans. Everybody threw stuff away in the 80s. In the 90s, people started getting ecologically aware, so we don't do that. Besides which, getting stuff out of the trash can. Ew. So the point is, a metaphor or a piece of language will capture a snapshot of history. It will tell you something about the time it was coined. Sprint was shorter than iteration, or the perceived idea. If you go back to 1990 and during the 80s, the language of iteration was not unknown. It certainly wasn't as pervasive as it is now, but it was not unknown. But when people talked about iterations, they were talking about spans of time that were 3 to 6 months in length. So when you say iteration, you're thinking seasons. You're not thinking months or down to weeks. You're thinking far. So in order to differentiate themselves, they chose. Jeff Sutherland chose the language that was much more direct, and also the idea of non-interruption. When you are running a sprint, it is not interrupted. It has a very clear goal. This language of goals is something that has been lost from Scrum as well, unfortunately. But that's why it's called that. It's not just gratuitous. And it's not simply about speed. It is actually because back then that did mark a valuable distinction, a distinction that quite frankly no longer exists. But what is a sprint? Now, when I look at how a lot of people are taught it and how a lot of people express it, a sprint is a vehicle. It's perceived as being a vehicle for delivering stories. Yeah, or story points, in fact, in the most debased version of it. The idea of user stories, the idea of functionality, the purpose of a sprint is to deliver functionality, and that is it. You commit to that and you're stuck with it, which doesn't sound very inspected out, very agile or whatever. Let's look at this. Empirical. How do we know what's going to happen in the next 2 weeks? Oh, by the way, that's the other shift as well. We've seen a kind of a war of duration. Okay, originally sprints were 30 calendar days. That's it, no debate. Pretty much these days everybody's on 2 weeks. A few people are on 4, some are on 1, and then you've got a few people out there who just want to be different and have 3 weeks. But so there's a very typical length. And the goal, what are we going to do in the next 2 weeks? We're going to deliver stories, we're going to deliver functionality. And that is the main goal. So you sacrifice everything for it, including code quality, which is a very common victim in this piece. Actually, let's go back. Empirical. What is it? Okay, let's actually understand what a sprint is. A sprint is an experiment. It's a period of time. It's a bounded experiment. What I'm going to do is in the next 2 weeks, we're going to try something out. Obviously, we're hoping for a good result. You don't launch into it hoping for a bad result. So we're hoping for a good result. Okay, so next 2 weeks, we believe that given our current knowledge, given our current skills, expertise, tooling, architecture, and so on, given everything we've got up here in the code base, given that, we believe that we can develop this much functionality in this period of time. Okay, there's belief. Okay, beliefs are fun, but they're not knowledge. And if you want to convert that belief to knowledge, you better try something out. This is this bit, the empirical bit. So you undertake a brief experiment. Rather than saying, we believe that, and it's going to take a year, you say, oh, well, let's just chip off a small piece. Let's have a go at this. We believe that in the next 2 weeks we can, given everything we've got, we're going to do that. What you're actually doing is not, you're not just producing software, you're actually producing knowledge. You're converting belief into knowledge. You are taking the givens, you're actually testing the givens. And to put it to break it into 3 very simple categories, there are 3 basic results from this experiment. Of course, there may be code, but hell, that's boring. Okay, let's not worry about that. Let's actually talk about the knowledge side of things. What did we learn? 2 weeks on, you can have hypothesis confirmed. Your hypothesis was, with all these givens, we can do this. Yeah, hypothesis confirmed. Result. Excellent. In fact, you could also have hypothesis exceeded. Our givens were false. We know way more than we thought. We're so much better than we thought. Our testing is just awesome. We had no problems. This turned out to be a trivial problem. What was estimated to take 2 weeks, actually we were done within in less time. So that's going beyond, if you like, the original hypothesis. There is, of course, hypothesis contradicted. In other words, no, we didn't prove it. It didn't work out. We had issues. We underestimated the complexity of the problem. So in other words, this is a lack of knowledge about the requirements. Now, when I say we, it is not just developers, I mean collectively. Okay, so people who are involved in understanding the requirements and articulating them. It's collective. Collectively, we lacked something. We were surprised by this. Okay, it's not what we expected. We can also be surprised by something in the code. We can be surprised by the complexity or issues that arise within the software architecture itself. There's loads of things that can happen. So that's not the result that we want, but it might be the result we get. You don't necessarily get to choose them. There's also another one, which is hypothesis not proven. Something else happened during the sprint, and we have no strong conclusions as to whether or not it worked out in our favour or not. This could be anything from half the team fell sick, and so therefore we couldn't really test the givens. We didn't achieve the result, but actually, given that half the team was off, that was not surprising. Or alternatively, there was a major problem in production, and it was all hands to the pumps to solve that, and we spent a lot of time dealing with that. So actually, we were distracted from the sprint goal. So the hypothesis is not proven one way or the other. Well, it's just fine. That's a defined outcome. But that's what we mean by this idea of empirical. It is you are running an experiment. Now, again, the language of experimentation can sometimes be intimidating for a lot of people because it sounds like you haven't got a clue. I mean, it turns out that in many walks of life, even when you don't have a clue, don't admit it. Use other words. Empirical is a softer word. Experiment sounds scary. Empirical and verification and confirmation, these are words that are business friendly, so favour those. If you're in a language where you can actually speak more honestly, or an environment where you can speak more honestly and freely, then the language of experimentation is much better. Okay, the next 2 weeks is an experiment. Now, if you want to fix the problems, you need to run experiments within your experiment, so to speak. Let's try this out. Let's change how we're going to do the testing. Let's change the tools that we're going to use. Let's change how we do daily stand-ups. Let's not do daily stand-ups, do something else. Let's mess about with the process a bit. And this is important because all of these things are perceived to be articles of faith. You must have a daily stand-up. In other words, we're going to go through the rituals of Scrum, and it does have rituals. All processes have rituals. The thing that is overwhelming, for example, if you ever do rational unified process, is that it has an abundance of rituals. Okay, it makes the Catholic Church look quite light by comparison. I'm my mother's Catholic, I can say stuff like that. So that's the point, is you have a set of rituals. And people think that the rituals are holy and therefore immovable, okay? We must have these artifacts, these things. We must have our daily stand-up. We must ask the magic 3 questions and so on. Not at all. There's another word, gnomic. Now, this is a slightly less common word, not to be confused with gnomic with a G, which means something slightly different. Gnomic is a very useful word, and I used it a number of years ago, forgot about it for a while, and then was reminded when somebody asked me, I said, well, what's the difference between an agile approach and an iterative and an incremental approach? Well, that's an interesting question, because a lot of people are getting into what they're referring to as agile development, but actually what they're doing is iterative and incremental development, which is fine, except that they're giving it the wrong label. Now, what is the distinction? All agile processes are to a greater or lesser extent iterative and incremental. The term iterative covers a number of aspects. Iterative refers to progressive refinement. It also refers to a cycle of time. So there are these 2 distinctive ideas. Depending on who you speak to, you get the emphasis on one or the other. It is possible to have an iterative process without iterations, for example. But the idea is that you have iterative refinement, it's progressive. You revisit things that you have already done and you improve them. In that sense, iterative refinement, as opposed to iterative life cycle where you repeat the activities. And so you have that aspect. So it's a relationship of time, if you like. And then you have incremental, where the emphasis is on we have this much stuff at this period in time, and sometime later we have more stuff. Therefore, there is an increment. Okay? And so we have that very simple view. And different process models have different emphases. So the rapid application development crowd 20 years ago tended to emphasize iterative processes and weak incrementality. In other words, you kind of come up with a prototype of an application and then you refine it into production quality, for example, as opposed to treating, slicing up the behavior into more discrete, trackable chunks. And so there are these shifts in emphasis. So there's a whole language here. Okay, so we repeat our activities, we produce increments and so on. Why is that not necessarily agile? Agile is the bit where you get to change things. The agility is a reference to adaptation. And it's this word gnomic that plays the role. Iterative, incremental, and gnomic, if you like. Now, Peter Suber, a philosopher, came up with the original gnomic game in the 1980s. It's this idea, a game in which changing the rules of the game is a legal move and part of the game. Okay, if I sit down, I can't play chess very well, but if I sit down with a chessboard and chess pieces anywhere on the planet, I can play a game of chess against somebody I do not share any language with. We can play a game of chess because the rules of chess are fixed and understood. They are very simple, yet they provide for very sophisticated behaviour, but they are immutable. Your first introduction to gnomic, or the gnomicacity, I'm not sure that's a word, nomicity, let's go with that one, of games is probably something like Monopoly. Okay? There are a number of pieces in Monopoly, a number of points in the game that are slightly elastic. You don't really realise that these are like this until you go to somebody else's house. And they do things slightly differently. We've started having this with our kids. You know, the kid will come around and say, oh, you do that in your house. You know, we don't do that when we pass go. Or we do it like this when we pass go. And, oh, you put the money there. Oh, we don't do that. Or we allow this when you mortgage something. Or we don't allow trading like that, and we do allow. So in other words, what you get is the house rules. Okay? And those are highly fluid, highly adaptable. And sometimes they're made up on the spot to appease a younger sibling and stuff like that. You know? But they are made up. There's a whole sort of secondary layer of knowledge that is built up around it. A full gnomic game, though, goes much, much beyond that. It sort of basically allows you to teleport around the Monopoly board and do other things and knock buildings down and reroute streets and all the rest of it. Now, that turns out to be impractical with a card-based thing, but this idea is that what Peter Suber was after is he wanted to explore legal systems and constitutional systems. Because in constitutional systems, it is down to the Constitution to change how the Constitution is interpreted. Okay, so you change the rules of the game. That's what we're doing. That's what Scrum is. Okay? And indeed many agile processes, that's what makes an agile process agile, is you get to change the rules. So I remember visiting a company a few years ago. I ran some sort of agile overviews and stuff, and one of the guys said, "Oh, good, we're hoping to learn." And I said, "Oh, okay, that's great. Yeah, because we want to write down our agile process after the course." I said, "But how will you know? How will you know if it works? You know, you can write stuff down. If he'd said something different, if he'd said, what we're going to do is we're going to start off with a position that is fairly close to what you have described and is not too far from what we're currently doing. We'll start with that, see how that goes, and see where we need to go next." It's more like a pub crawl than anything else. Okay? There's not a lot of planning to it. Okay? And the idea is that it's sort of meandering. That's what you want to hear. But when somebody says, we're going to write down our agile process and that's it, well, there's no agility, there's no nomicity. Okay? The whole point is you're supposed to be able to say, you know what, that 4-week iteration isn't working out for us. We're going to switch to 2 weeks. Our idea of and one of the simplest tools that is overlooked in this sense, is the dial of control that you have, definition of done. The idea that when somebody says, oh, we're done with this feature, how do you know that you're done? The problem is that done is a word that people share at one level, but the meaning is very fluid. So the idea is we choose a definition of done. Okay, we choose one that is achievable. Don't choose one that's perfect. The problem is that people sort of choose one that's so unachievable, there's no way they're ever going to achieve it. On the other hand, you choose something so low, it never has any meaning. So the idea is that's your dial. You adapt. You adapt as you go. You say, oh, okay, we're pretty good with that. Okay, turns out that coverage approach that we were using as a criterion for our test, rubbish. Forget it, we're going to use a different approach. The way we were doing code reviews, that was bottlenecking the whole process. We need to do something else, and so on. So you're going to experiment, and some experiments are not going to work out, which is fine, because you're running lots of them. That's the idea. But the idea is you are going to change the rules. Now, Peter Suber, in the original Nomic, he made the original rules for Nomic very boring. He made the game very boring. So in other words, when you were playing it, one of the first things you want to do is change the game so it's more interesting. I like to think that Scrum is like this, because the basic rules are really quite dull. You want to make software development fun. And this is also important because it means, by definition, that every single software project will have its own process. Because you may all start in the same place, but by definition, what you're trying to do is play the game, and here I'm kind of switching into not so much sports metaphors, an observation from Alistair Coburn, one of the 17 signatories to the Agile Manifesto. He made the observation that there are many different kinds of game. Software development is a cooperative game, as opposed to a competitive game. And it is not played to a defined outcome. In other words, you don't stop and that's it. The idea is it's actually a long-term game. Okay, so it's not a 90-minute thing or even a 4-week thing. The idea is that it's a very open-ended game. And it's not a zero-sum game either. So there is this idea that what you're doing is you're changing the rules of the game to make it more fun and more appropriate for your project. And it may turn out that based on your skills and the nature of what you're doing, you're going to end up with a very different set of adaptations to what another team is doing. You may actually opt out of Scrum or whatever process you started with and move somewhere else. You know, there's that constant series of experimentation may tell you, yeah, this isn't what we wanted. Well, that's a very important kind of key idea. So this is the issue. How do you certify somebody in this? Sit down and say, make Nomic Monopoly, and we'll see if you can do this really well. Make an interesting game. That's probably better certification than can you recite the rituals. The idea is, can you change the rituals? When somebody gives you a problem, can you come up with at least 2 alternatives? The idea is that you can only come up with 1 alternative. That's not very good. Okay? Emile Auguste Chartier observed there was nothing more dangerous than an idea when you have only 1 idea. Okay? If somebody in your team, you're doing a retrospective and somebody, how are we going to fix this? And somebody comes up with an idea. Don't do anything until you get a second idea. Okay? The first idea may be brilliant, but until you have a second one, you cannot compare meaningfully. So it turns out this stuff's although this is in one sense really well defined, we have a challenge. How on earth are we going to learn this stuff? How are we going to adapt? How are we going to discover stuff? So we then wander into this minefield of myths about how people learn. There's this kind of standard thing. There's two harmful mindsets floating around. One is failure is bad. The other is failure is good. Yeah? Real world does not come in these favours of black and white, which is why I chose an interesting shade of grey for the font. But you don't have to go very far to kind of see the idea that failure can be considered a very bad thing is certainly endemic in business, but the pendulum swings to the opposite extreme. We see it. This was in Financial Times a couple of years ago. I didn't have to Google very far, and there it is. Failure is a far better teacher than success. Yeah, this is part of like standard business law in some sense. Christopher Walken. If you want to learn how to build a house, build a house. Don't ask anybody, just build a house. Great actor, lousy teacher. This is terrible advice. How many ways are there to build a house incorrectly? And do people's lives depend on it? You see, if people's lives didn't depend on it, that'd be great. But the problem is, you're standing there looking at a house going like, well, I think it's really interesting the way that none of the doors have got any right angles on them. And, it all looks a bit crooked. Are you sure that it's safe to go up those stairs? Oh, yeah, I'm pretty sure it's safe. Are you pretty sure or you know that it's safe? Well, I'm pretty sure. It fell down last time, but I think I've got it this time. The thing is, there are a lot of ways this stuff can go wrong. It turns out that the failure space is far, far larger than the successful configuration space. Basic physics tells you that one will outnumber the other. The use of failure as a guide is really not very helpful. And what we're doing here is we're doing something fundamentally in opposition to, I used this quote last year in the question craftsmanship talk, and it identifies with this idea of community. This is a solved problem. The basic stuff about building houses, it's a solved problem. How to wire your house so that it doesn't catch fire, it's a solved problem. Okay? These are solved problems. We can try and reinvent the wheel, or we can actually try and, get beyond the wheel and actually have something that moves, something interesting. If we're relying on everybody to learn through every single mistake that has already been made by other people, people will, trust me, when you give people something that is well defined, they will still find new space to make their mistakes. That's called learning. We will do that. But as a vehicle for learning, this is profoundly unsuccessful. What you want to do is learn from somebody who does build houses. Get the knowledge. Get the knowledge. It turns out we've built software systems before. It turns out that many things are well known. That's when you come to a conference. You go and see what other people know and go, oh, that's really cool. I haven't seen that before. Or, oh, I know that doesn't work. They've probably not tried that. So this is the point. You learn from other people. When the original Agile Manifesto said, we are uncovering, it didn't say, I am uncovering. It said, we. It's a collective kind of sense. This is really important. Human psychology just does not support the idea that we can learn complicated things through a simple process of trial and error. It's one of my favourite examples. Some of you have seen this. Ecce Homo, behold the man. This was actually painted in the early part of the last century. It's in a church somewhere in Spain. And, it wasn't doing too well. People thought, you know what, we need to restore this. So a little old lady, about 4 years ago, Cecilia Jimenez, she took it upon herself. She's a self-taught artist to restore it. Much to the shock of the family of the original painter, and indeed the church itself. But the church quickly changed their tune. They're actually raking in an absolute fortune at the moment, because people are paying to come and see this. This is helping restore the rest of the church. Cecilia Jimenez's family is now trying to sue the church for a portion of the profits. Anyway, that's well beyond the scope of this talk. The problem is that if we just teach ourselves, if we just learn by trial and error, you end up with stuff like that. I've seen software that looks like this. Okay? I mean, if you can imagine, visualize the code base, I've seen stuff that looks like that. This is not painting. There's a whole schooling of techniques you can learn from other people, it turns out. We're not very good at doing this stuff. So there's a couple of things. The assertion we can learn something from every failure is often heard. A study carried out by Al Miller and colleagues at MIT test that notion by looking at learning processes at 11 neurons. The study shows how brains learn more effectively from success than from failure. This doesn't mean that we don't learn anything from failure. It just means that it turns out that we learn by imitating success. If you want to learn how to play a piece of music, you can either have somebody sit there and tell you you're doing it wrong, or you can listen to it being played correctly first and then try and figure it out. Okay? So I've had my kids they've learned various things. The older boy, let me think, he's on his fourth instrument now. He's decided drums because you don't get the notes wrong. But when he was learning piano, if he was learning a piece, the piano teacher would play the piece first. So now you know what it sounds like. Rather than, okay, try and play that, but I don't know how to play it. Try and play it. Bing, wrong. Bing, wrong. Are we learning it? There's a lot of things that you can do that are not right. That's just not a very good way of learning. Brain cells keep track of whether recent behaviours were successful or not. When a certain behaviour is successful, cells become more finely tuned, in other words, become reinforced. But the opposite does not really work. After a failure, there's little or no change in the brain. There wasn't any improvement in behaviour. Now, a larger one, an example, and I think actually Alan Kelly, lurking in the back there, sent me this one originally. Okay, we've done the neurons. What about the people? What about the businesses? David Story, in a piece from about 6 years ago, I think, in the FT, it's become commonplace to suggest that failure is good for entrepreneurs. Okay, it's become an article of faith in many ways. In this view, failure that comes early in a founder's career can teach them important lessons about doing business, harm them for the next startup attempt. Okay, we have laws that are structured based on this belief. We should allow somebody who's become bankrupt to get back into business more quickly. Turns out that that's actually not really what's going on. In the UK, the evidence is that novices are neither more nor less likely to have a business that either grows or survives than experienced founders. In Germany, where more extensive statistical work has been undertaken, it's clear that those whose businesses failed had worse performing businesses if they restarted than did novices. This is almost but not quite the Monty Hall problem. Now this is really interesting because what's actually going on? Do people, when their business fails, and this is proper failure. The other thing I want to talk about is the elaboration of the language of failure. People say, oh, learning from failure, and then they'll point to something. Oh, that sprint didn't work out. That was a failure. No, it wasn't. That's why we have sprints. Failure is when the project doesn't work out. The company goes bust, and the people are turned out onto the streets, and mortgages lapse, and houses are collected. That's failure. We didn't quite achieve the objective for the last 2 week sprint. That's a failure? No, I don't think so. That's why we have sprints, to avoid failure. Yeah? So the idea when people sort of say every little thing, oh, it's a failure. No, it's just a little error, it's a minor deviation. It's kind of, oh, that's a minor point. Failure is when it all goes horribly wrong. You really don't want a lot of those. You'd like to make sure that you have these kind of little checkpoints en route. But it turns out that the way people approach this is their technique, their approach for doing things becomes very personal. It's like the self-taught programmer and some of their quirks in style. And it's like the self-taught house builder. Yeah, those doors, none of them. There's no right angles there. Oh, that's just my style. People start to identify with themselves. They personalise it. They internalise it. You look at people's coding practices and say, whoa, you haven't done any programming with other people for a while. That's just my style. As if that somehow gets you off the hook. It doesn't. It's a point here is that you become attached to something that we don't necessarily know is a good idea. And it turns out this is the same thing. When people's businesses fail, a very typical deep reaction, it's called being human. There's nothing, they're not being stupid or anything like that. It's very, very typical human behaviour. It's what you do is you become attached to the way that you did something. This was my project, this was my baby, this was my business, this is how I thought I was going to go about it. And it didn't work out that time. And you will identify something that you think is relevant. The timing was wrong, we were ahead of the curve. Yeah, we didn't get the funding model in time. Oh, it was that particular programmer, he wasn't any good. If we had perfect programmers, good God, if we'd had perfect programmers, the world would be a different place. That's not going to happen. If we'd had this, if we'd had that, and then you say, right, so next time we're going to do exactly the same as we did before, except for that one thing. And we'll do everything we did before harder, which may sometimes, or often, equate to, we're going to do the wrong thing, but with more conviction. And that gives you an explanation for what's going on here. Some people will kind of take a step back and balance out the statistics by going, oh, wait a minute, you know what? Profound insight, do something else. But a lot of people are not. That's what keeps the statistics looking like that. Okay, so people don't really use the lessons of their own experience. Now, why does this stuff matter? Again, this idea of learning from failure is integral to a number of things. There's a shift in the language of Scrum a few years ago, and it's visible in the Scrum Primer. I noticed it at a couple of talks. I don't think it was Jeff Sutherland, I think it was a Ken Schrader talk. When they started talking much more about the organisational side of Scrum. Rather than the we are learning to develop software approach, we started ending up with this kind of discussion of the organisational aspect. Scrum works by making visible the dysfunction and impediments that are impacting the product owner and the team's effectiveness so that they can be addressed. Leaving aside the profound business speak that's going on here, impacting. I'm not entirely sure that wanted to be a verb when it was coined originally. Just addressing points of effectiveness, it seems a little clumsy language-wise, but the Scrum framework will quickly reveal these weaknesses. Scrum does not solve the problems it developed, it makes them painfully visible. This was clearly written by somebody else because the two successive paragraphs, the language is different. 4 people wrote the Scrum primer. But you can sometimes spot people's different styles, okay, just as a point of reading. Notice that the choice of words is completely different. This is direct language, uses much more conventional English. Scrum does not solve the problems developed, it makes them painfully visible, and provides a framework for people to explore ways to resolve problems in short cycles and with small improvement experiments. So yes, it uses the language of experimentation, but there is this assumption that what you're going to do is you're going to expose, we're going to show you that something's wrong. Hey, look, it's broken. Great. What do I do next? You figure out how to fix it. Right, are you going to help me with that? No, but we'll let you know when you're done. It's kind of like I've got a loop. I've got a termination condition, but I have no idea what's going on in the body. So it's kind of meta. This is why people call Scrum, and indeed Kanban, and other processes frameworks, because they are incomplete by definition. It's up to you to provide that. And that's not necessarily a problem, but that idea that we're actually going to do something just by exposing faults is open to question, I would say. So this is not new knowledge. This goes back a couple of thousand years. Wise men profit more from fools than fools from wise men, for wise men shun the mistakes of fools. But fools do not imitate the successes of the wise. This is one of the things, it turns out, that differentiates us from chimpanzees and other primates. The observation made by a guy called Mark Pagel at the University of Reading, that other primates are restricted to learning by, primarily through trial and error, but human beings imitate. That's one of the other things we do really well. Hey, that looks really good. I'll do that. Unfortunately, it gives rise to things like the fashion industry and other things like that. But you're always going to get a negative with a positive. But that's the point. We sort of say, that's interesting. I like that. You go to a restaurant, I want what they've got. That looks good. It's not just an independent thing. It's not I just want food. We've actually got a little more sophisticated. So there is that idea that our skill is through careful imitation. Careful and selective imitation, which is, if you like, patterns, which is one of the reasons I'm kind of interested in patterns. However, let's talk about knowledge. All the way, indeed, that sometimes it doesn't work out. Now, this is Nassim Taleb's first book, Fooled by Randomness. He did a follow-on book, which is very much on the same topic, called The Black Swan, which I did once have to clarify to somebody had nothing to do with the Natalie Portman movie. There were no ballet dancers involved at all. This is all about probability and surprise, if you like, and extreme probabilities. He's also the author of Anti-Fragile, which came out last year and has got people interested in his work. Very simple observation. People overvalue their knowledge and underestimate the probability of their being wrong. Now again, what we need to do is have software development processes that are sympathetic to the individuals. Okay? In other words, this is how people actually think. So one of the things that Agile has responded well to is very much this idea that people often, they're not going to be able to estimate successfully. And you need, if your whole project is based on a very fragile sort of house of cards of estimates based on stuff that is incomplete in terms of our knowledge, and you ask people, how certain are you of it? It's one of those classic things. If you push somebody for certainty, they will give you certainty. Those figures you gave me, how certain? They will respond with certainty, because they wouldn't respond with anything else. Why would they say, oh yeah, I just threw those together, they're just random. Nobody's going to come back and say that. Well, actually, I gave you those, but I didn't really express what I felt. People don't do that. It's just that's not a human thing. I mean, we can say, oh, people should. Should is a very dangerous word in this context. People don't do that. You have to create a process that is sympathetic to people and how they actually work, not how you want them to work. So we need to understand stuff we don't know. It turns out there's different ways of ranking our knowledge. This is my favourite. This is from Philip Armour, 5 Orders of Ignorance. Naturally, it numbers from 0, which I was quite liked. And he wrote this, God, how many years ago? Communications of the ACM. Must have been about 2000. Well, I was still reading it at that point. I just nearly received it now. So it must have been about 2006, 2007. I think it's available elsewhere online if you go and Google that. Okay, 0, lack of ignorance. What does that mean? It means you know something. You know what you know. 1, lack of knowledge. You know what you don't know. Now, these two are not treated equally. Okay? In your mind, here are the things that you know. Around the edge is a little narrow band, the things you know you don't know. Okay? It's kind of like looking towards the horizon. Okay? There are things that are near you, there are things that are far away. You pay less attention to those things that are far away, even if they're as big as the things that are up close. Because there's almost a self-serving loop that goes on. Things that you don't know aren't as important as the things that you do know. Because otherwise, if they were important, you'd know them. That's the way your brain works. I'm sorry, that's just how it is. Yeah, you can't sit there and rewire this in your head. This all happens before it hits your stream of consciousness. You automatically rank stuff. I don't know about that, therefore it's not as important. It can't be as good as the stuff that I do know, because the stuff I know must be important because I know it. And I am indeed the centre of the universe. Yeah, there's that. Unfortunately, that's the way your brain works. It has a very simple model. But nonetheless, there is an acknowledgement. Sometimes we can quite clearly state, I don't know that. We're going to have to look at that in more detail. I know that I don't know that. It is unsurprising that I don't know that. Okay? So I know how to speak English. I also am utterly unsurprised by the fact that I don't know how to speak Japanese. Okay? There's no surprise there. So I don't suddenly arrive in Japan and go, well, you know what? I don't speak the local language. That was a big surprise. Although that sometimes feels like some software projects. It's just like, okay, we're using a completely new technology and nothing's working out according to plan. Wow, that was a big surprise. It's like, no, really it wasn't. But the problem is that most software development most of the fun in software development doesn't happen at 0 and 1. It happens in this space here. Oh, there's good news about 4. It's good, the news is going to get darker as I go through 2 and 3. But, there is sunrise at 4. Lack of awareness. This is your classic Don Rumsfeld unknown unknowns. You didn't even know you didn't know something. How on earth are you supposed to estimate that? I mean, it's quite tough estimating for things that I don't know, but, I didn't even know I didn't know that. Let's pick a very simple example. One of my favourite examples. One of the things that I dislike about some of the ways that sometimes people manage their backlogs in Scrum and in other processes. When we estimate, if we estimate how much effort a user story is going to take, so how much effort is involved in this feature. First of all, we provide a single figure, which I find deeply suspicious, but we'll come back to that in a moment. How well do we know this? Well, we've never implemented it before, so we don't actually know how good that is. So really, we should be providing a single figure. We should be providing more of a range, but we can deal with that. So we think we know stuff, and there's a bunch of stuff we know we don't know, but we think that we're familiar with that. So we work within the 0 to 1 space. And occasionally we get bitten by stuff that happens here. The problem that we encounter is primarily to do with bugs. Bugs are my favourite example of stuff that you cannot estimate. Not, here is our bug list, how long do you think it's going to take to fix? But you've just delivered a release. How long is it going to take you to fix the bugs? What? Well, we don't know that we've got any bugs. Yeah, I know, but I still need a number. In other words, the point here is we don't even know what it is that we're trying to estimate. It's not even a case of like, that's a bit tricky, we don't know about it. It's like, I don't even know what it is that is tricky. You're one level removed. Estimating for bugs is shifted on. I don't even know where to begin with this. If you say, we're going to develop a product, we're going to spend 12 months developing it, how long are you going to spend fixing the bugs that happen in your first release? I have no idea. Hopefully we'll have no bugs in the first release and it'll all go well. Hope is a wonderful thing, but it's very difficult to put in a project plan. The point here is people are profoundly surprised by this stuff, repeatedly. This is very much the NASA Tower thing. So you don't know you don't know. Oh, okay, right. So my favourite one in terms of languages is, I I can speak Brazilian Portuguese, not particularly well, but my big surprise when I was a kid was going to Portugal and discovering that, you know what, they speak a completely different kind of Portuguese. I had no idea what they were saying. I did not know that I did not know how to speak European Portuguese. That was a big discovery. But it turns out it's not a difficult discovery, because the real problem is lack of process. You don't know how to find out that you don't know something. It turns out that the Portuguese question is quite easy to answer. Fly to Portugal. Yeah? Oh, guess what? They speak something different here. These days it's slightly duller and more disappointing. Go online and download some European Portuguese. Oh yeah, it sounds different. Not as much fun. I was hoping for some sunshine. Oh, I guess we got some. You don't know how to find out. This colours an awful lot of stuff. We need to be really careful with this. Our product is going to be successful in the marketplace. How do you know that? How would you find that out? When somebody ranks, so let's actually look at one of the profound repeated dysfunctions in terms of language. When somebody says, okay, here are our features, could we prioritize these features? Prioritize the user stories according to business value. It is not possible to prioritize features according to business value unless you have a time machine. You have no idea how to find out what the value of that feature is until you do so retrospectively. The best you will ever do is to prioritize according to estimated business value, which is a completely different concept. You cannot prioritize according to business value unless you're on Doctor Who. Which I'm going to take a wild guess. I'm fairly familiar with the various regenerations of Doctor Who, but I don't see anything in the room. So it's actually not possible to do this thing that people say you should be doing. You have to add an extra word in there, prioritize according to estimated business value. That's a completely different game, completely different. This is really hard. We have no idea of finding out how. Good news, number 4, it's all got darker, but that's good news. Level 4, you don't know the 5 orders of ignorance. Well, you do now, so that's one you can cross off the list. Okay? But the problem here is what I've highlighted, going back to the Nancy Taleb quote. People overestimate the value of their knowledge. It's not all doom and gloom, but unfortunately, most of what surprises us, a bug, is out here. A clarification of requirement is out here. Oh, that's what you mean by that. The fact that the third-party product that you were going to lean very heavily on does not quite fulfill your needs. Guess what? That's out here as well. Fortunately, we do have a process, but we may not have actually expected it. So there's a whole load of stuff. All of these things that we kind of pass off and say, oh, well, you know, next time around. Well, no, next time around it's going to look exactly the same. It'll just be something different. It's not that we can't negotiate it, it's that actually that's where most of the core fun, or where the massive deviations in time and effort actually lie. And this is the problem is that we are very blind to this. We value very much the things that we know, and we work according to that. So therefore, it's very difficult for you as an individual to get outside what you know and say, yeah, I'm going to take my starting position is that I'm an idiot. Yeah, I'd love to see that at the beginning of some kind of project mission. We are all idiots. You know? This is our starting position. This is our working assumption. We have no idea what we're doing. Oh yeah, we can code a bit. We're pretty skilled with that. But beyond that, all bets are off. We're out here. Okay? But we've got some really good ways of finding out. That's what we're trying to do here. That's a basic element of human psychology. XKCD break, yes. Author of the Windows File Copy Dialog, Visits and Friends. And the point there is that we generally do this repeatedly and get some state. So I referred to individuals a moment ago. Individually, it's very difficult to do this. Collectively, we might be a bit better. Now, this book, very influential, James Wiki, came out in 2003, Wisdom of Crowds. The phrase has gone into business speak language, but there is very careful the idea that many can be smarter than a few. However, there are some strings attached to this. So this is where the interactions come in. This is where we define the concept of teams and organizations. And when we use words like collaboration, what we actually mean is this stuff. He placed 4 very specific conditions on this. 4 conditions that characterise wise crowds. Diversity of opinion, independence, decentralisation and aggregation. Diversity of opinion. Not everybody thinks the same way as you. Otherwise you end up with groupthink. Now this can be very, very difficult because we find this in large organisations and small organisations, often for different reasons, but ultimately it comes down to recruiting people like us, and that becomes a bit of a problem. With large organisations which have a very sort of a fair instrumental engine, if you like, for recruitment. My wife used to work in one of these. There's the people like us thing that defines a sort of set of company values and so on. You don't really rock the boat too much. But we also see it with startups, recruiting people like us. A friend of mine ran a startup many years ago and recruited people like him and the other founder. And they got rid of people that didn't quite fit, which is unfortunate because it turned out people that didn't quite fit had some really good ideas. It's just that they weren't the same ideas. And they were really good developers. It's just that they developed things in a slightly different way. I have to say that was always quite an experience sort of going in there. So I'm like, yeah, these people are really smart. But collectively, you can get a lot of people collectively actually have a remarkably low IQ. Over here in the UK, we call that Parliament. It's just around the corner. Okay, that's our version of it. Other people have different constructs for this. Diversity of opinion. You don't want people that are just like you. I'm not saying go out and recruit complete idiots and outliers, people who are often defined as toxic. In other words, people whose behaviour on a team, presence on a team, effectively destroys the team. That's different. That's fundamental personality mismatch. And that toxic individuals, they are a problem. And try and avoid the psychopaths. They're out there. They're all over the business landscape. But diversity of opinion. Just because somebody doesn't necessarily agree with you, that's not a bad idea. If you've got a team full of C# programmers who all have exactly the same background, do something wild. Get somebody who's not a C# programmer in, and is just interested. They don't have much C# experience. Fine, just as long as they're interested, that's great because they may do something else that's really kind of neat, or they may call into question an assumption that has been sitting there that everybody's been staring straight through. Likewise, age. If you end up with people of the same generation, that's a bit of a problem. Okay, you want to have a diversity. So sometimes I will go into companies and I feel, yeah, I'm the oldest person here, and sometimes I'll visit a company and I'll feel slightly depressed because I'll be the youngest person there. I've now learned that that's a bad thing. Yeah, I've now reached that point where I should not be the youngest here. But it's that notion of I should not look like everybody's grandfather. Yeah, there should be an age distribution. You need some diversity there. It's a very obvious point of diversity. Independence. People need to operate independently. Now, we see this again with things like estimates. If you're going to estimate as a group, make sure that you do so in a way that doesn't bias other people. You influence other people without even realising it. Questions of seniority either granted by the hierarchy of an organisation or simply because, well, you've been there 10 years, you clearly know your stuff. I'm just a newbie. You just estimated that this was going to take, like just a couple of weeks, and I'm sitting there like, ooh, that's a 3-month job at least. I don't want to look like an idiot, so I'm going to estimate down. So people need to operate independently. And decentralisation, that we are not relying, this is an extension of diversity, we're not relying on the same sources of knowledge. People are not just looking at the same things. Now that's also quite important because particularly just generally in terms of how people operate, we are living at a time when we have access to an incredible amount of knowledge and a disproportionate number of pictures of cats. I want to focus on the former rather than the latter, although I did recently observe that a room full of people developing software is almost indistinguishable from a room of people looking at cats on the internet. If you actually look at it, it's not as exciting as it is in the movies. It's just like it would make for a very dull film. Oh, okay, something's happening. Yeah, it still looks like a room full of people looking at pictures of cats on the internet. It's really not dramatic, and the lighting is just not like it should be. But if anybody runs a company where it does look like that and you get the screen projected on your face, I want to work there, because that's obviously very dramatic and quite cool. The idea that people are not just relying on this, but we have ended up with a narrowing as well. The great thing is, these days, if you have a problem, you can go out on the internet and look at it. Meta problems harder, in other words, organisational issues, and so on can be harder to find. There's no real Stack Overflow for that. But there's this idea we are operating, taking advantage of individual intelligence and the independence that can provide collectively, but unless you collect it, it's not collective thinking. Aggregation, you've got to bring it together. So this is why a lot of the practices that we see in agile processes, if we deconstruct them, they work for various reasons. Because either they allow people to operate independently and then bring them together. Your code base, for example. Code is a collective enterprise across a team. It's an expression of that. So therefore, that is the collective base of knowledge. Sometimes that's quite scary when you realise that. Oh my God, is that how messy our knowledge is? Yeah, it might just be. But aggregation, the process of bringing your knowledge together and refining it, that's the bit. So when we talk about code as being a repository of knowledge, as opposed to in some organisations it looks more like a suppository of knowledge, the aggregation here is very much that how do we work together to work this? This is wikis, this is code, this is retrospectives, this is all of the stuff that it's a very delicate balance. Otherwise you end up with groupthink. Little correlation between groups' collective intelligence and the IQs of its individual members. This has been proven time and again. It turns out that there are a number of different ways of doing this, dealing with this one, but this particular piece of research revealed if a group includes more women, its collective intelligence rises. So, I have to say, ever since that, so this research, this isn't what they were looking for, but they had enough data and carefully controlled the data input. What they were looking for was a number of things, and this one came out. We can attribute this to a number of different things and explore that, but that's outside the scope of this talk. Communication styles, how people, a group of blokes does communicate differently, and there is an unguardedness sometimes that changes when you have when you change something fundamental in the team. This is one of the most obvious things to change. Ever since then, whenever I run workshops, I try to be fair to all the teams. Appropriate number of women in the room, then I will make sure that no team gets more than its fair share of women, because I don't want that to be an unfair advantage. Yeah. But there's these little things. Again, there's tags on the diversity thing. Let's look at something else here. In other words, processes and tools are processes that emerge. In other words, we start with this, individuals and interactions. A process is simply a way of describing how people organise their time and what they're doing. It's the who, what, where, when, why. Okay, that's what a process is. Sometimes people say, oh, we don't have a process. We don't need no stinking process. Well, that's your process then. Whatever it is that you're doing, I can observe you have a process. You may never write it down. You may never be aware of it. But I can send in an anthropologist. In fact, there have been anthropological studies of software teams. Almost going in, it's like, tribe in Borneo, software developers in Shoreditch. It's kind of like, it's a little bit like that. Okay. Observe them. Don't interpret what they do. You go in as an ethnographer to just merely observe what's actually going on in terms of the exchange. And you can define a process for what they do, their rituals and how they work. Process doesn't need to be written down or even be something that you're aware of. All teams have at least one process. There's the one they say they do, and then there's the one they actually do. But you can do this just by observing it. So when a team says they have no process, they're lying. It's just that they may not wish to formalise it and give it a name. That's a different thing. That's entirely reasonable, but that's a different point. But this is the point, is that emerges out of that rather than being imposed. The tools should support that. And of course, the tools make certain things easier. But the tool, a number of times I get asked to go in and do a training course based around a tool, and I'll actually ask, what do these people actually do? Well, they don't need tool training. What they need to do is be trained in something else that will allow them to make sense of the tool rather than allow them to be driven by the tool. So that's an inversion of control. However, what I want to focus on here, working software. What's the shift? What's the shift here? So there is another observation when we talk about sort of the language of teams and organisations and interactions. People often talk about the mythical stakeholder. For me, stakeholder will always be Buffy. Okay. You're not going to shift that. You can sit there. I mean, just one of those. It's just one of those things that makes you smirk in meetings, like when somebody says, when somebody talks about the enterprise, and you're thinking NCC 1701, and you know, it's just stuff like that that keeps us vaguely amused. You know, don't dress it up. It's just a business, and it's a stakeholder. Who is that? Is that just somebody that cares about the outcome? Right, say so. Now, the reason this is important is because we use this word a lot. Agile methods balance two things. One is the maximising of value creation. The other thing is the maximising of the chances of actually delivering something. What we're doing here is playing a very careful game of probabilities. People are operating, I made the point earlier on, people are operating, they are imposing certainties. If you ask people for certainties, they will give you those. Are you sure about this? Yes, I'm absolutely sure. When we talk about estimates, I said earlier on, you know, estimates, I feel very uncomfortable with the way that we work with estimates, and this is, there's a whole discussion here, but one of the simplest things is that when somebody estimates something, and they give you one number, that makes me feel very uncomfortable, because an estimate is actually, it's at least three numbers. Okay, it's you need to define the shape of a probability distribution. That's unfortunately what it is. There's no way around it. What you're doing is you're saying, well, there's an earliest likely date, median date, and then a kind of a typical one standard deviation out beyond that date. And that can be wrong because it's Bayesian probability, but you know, the point is it's open to adjustment. But the idea is you need to give, when somebody actually wants you to give them an estimate, email them an equation that characterises the based on our current understanding, this is the probability curve for these values, because that's what you're doing. What you're doing is saying between the probability this will be delivered tomorrow is 0, the probability that it gets delivered by the heat death of the universe is 1. Somewhere between that it actually gets delivered. Okay? And that has a shape, and unfortunately it's not a symmetric shape. This is another thing we need to get away from. All this is wired up to a very, very simple model. When we look out at the world, we see things vary in very systematic ways, and most of the things we notice vary in a symmetric way. What I mean by that is if we go around the room and we take shoe sizes, then that will probably look like a Gaussian distribution. What is the other name for a Gaussian distribution? Bell curve, yeah. And the other one?
Normal.
Why is it called normal? Because it's normal, exactly. That's why we call it a normal curve, because it's the typical thing. We go and measure people's heights. You go and look at all these things. They come out looking like this. It's normal. You are tuned to see this in the world, and profoundly surprised when it doesn't. Okay? Delays, for example, don't look like this. Yeah? Train delays, flight delays. Anybody been on a flight that's been delayed 2 hours? Yeah? Anybody been on a flight that turned up 2 hours early? Not so much. Okay? They're asymmetric. Okay? A half-hour delay is not unusual. Half-hour early is more unusual. Okay? So it's asymmetric. The problem is we're not very tuned to see that. So we assume that our estimates average out. They only do that if they're symmetric. They're not. That's why they take, even when they're quite good, they will naturally tend upwards for a larger project. And that's even leaving aside all the other knowledge stuff I talked about. So it turns out that one of the issues, and going back to this question of surprises and chances and so on, one of the issues here is this one. People focus on, we talked about the value, estimating business value. What about the probability of it? It doesn't matter if a feature is going to be a market winner, is if your ability, probability that if we develop this feature, it will be a market winner, 50%. Probability we can develop this feature, 1%. Well, it turns out the 1% here is far more important. And you need to balance that, you need to figure that in. So the point here is that these are not always the same. So prioritization is not just by this estimated business value, it's also by feasibility. What are the odds that we can actually do this? Oh, this is really, really hard. It's so hard the company could go under if we don't get this one right. It's going to take so much effort. Projects that dogmatically focus on stakeholder value are working on the right things but still risk failing completely because the probabilities we get them. They are working on things that if they work will be great. If they work out, they will be great, but the probability of them working out turns out to be the greater challenge. They are high-risk options. And this is one of the points that Nicholas Bjornstad makes when he talks about this observation that working software is one of the primary ways of ensuring the system is being worked on will actually work. In other words, regardless of your aspiration, so for example, when we talk about business value, it is normally aspirational. We would like it to be this, but we very rarely factor in, what are the odds it's going to work? How difficult really is this? We've never developed anything like this. We're using new tech, new team. Everything that's new increases the risk by a remarkable factor. So you want feedback. And again, it has to be concrete and real. You'll never acknowledge your shortcomings otherwise. So this is why this stuff works. It works with the way that humans work. Right, I'm going to skip over that because I talked about that one last year. I'm going to skip over that. Oh yes, and actually I'm not going to skip over that because that actually dovetails rather nicely with the way we're going up here. What about motivation? Motivation, observation from Dan Ariely, who's a behavioural economist. This observation that downgrading bonuses, many Americans reading the news with unqualified approval, joy even, the policy fits well with our human instincts for justice and revenge. So bankers get paid too much. Right. Bankers, of course, argue fairness has nothing to do with it. And they're right, yeah. Patient structure to recruit certain kinds of talent, people like us, in other words, if that's a failure mode. More than anything, argue bankers' pay should motivate. Huge bonus checks are to ensure superior performance from superior talent. On this point, the bankers are wrong. We've recently gathered evidence suggesting dangling exorbitant sums of money in front of workers doesn't improve performance. If anything, it negatively affects it. It turns out that this is not just new knowledge. The research in this goes back to the 1960s. And was even motivation enough for Dan Pink to talk about it on Talk of Motivation. If you want people to perform better, you reward them, right? But that's not happening here. You've got an incentive designed to sharpen thinking and accelerate creativity. It does just the opposite. It dulls thinking and blocks creativity. It turns out that money is a motivation up to a point. Beyond that point, it turns out to have a dysfunctional side. It also turns out that money is a motivation for certain kinds of tasks, typically defined tasks. If I gave you a bonus for, I don't know, sorting beans, okay? Let's say we have beans in different colours, and I need you to, well, let's make this much more exciting, M&Ms, okay? Okay? And I want you to sort them by colour. Okay, sort them by colour, great. Now I'm going to reward you for sorting more in less time. The chances are that would probably have a positive effect, because the task, the nature of the task is defined. There are a number of things you can do to try and improve that. It's a very concrete, very manually driven task. There's not a lot of intellect that goes into it. Of course, if you're a program, you're sitting there thinking like, okay, forget the task. How do I write a program to do the task or create a device that will do the task for me? That's much more interesting. But let's just deal with the rest of the population at this point. That's fine. The problem here, though, is that this isn't the nature of tasks like banking, tasks like programming. All of these things have a very different intellectual engagement. And it turns out, for people who are intellectually engaged, the money doesn't work after a while. Once you reach a particular point, it just doesn't have the right effect. And actually, it's not that it has no effect, it actually goes into reverse at this point. For example, one team was given a, one team was, I just did some training for it, I didn't do any consultancy for them, but I made one comment in the training course and the room went silent. You always know there's something, you've hit a raw nerve there. And it was about pursuing 100% statement coverage as being a fairly foolish endeavour. Particularly if you weren't doing test-driven development. But the idea of pursuing that metric, it's kind of like you're just a greyhound chasing the automatic bunny as it runs around. It's just like, it's a foolish idea. And because there's a little bit of sheepishness in the room, some uncomfortable expressions, and one guy said, well, we've got a bonus riding on that. Somebody higher up thought, oh, so great, it wasn't, so good thing, it wasn't targeted at individuals. So in other words, at that point you start playing a zero-sum game. So what's going to happen is I'm going to get ahead of everybody else. I get the bonus. Okay, so at least it's done at the level of the team. That's great. But the problem is you don't want that even then. And this is the issue. What had happened is, programmers are pretty smart. Okay, you're talking about if you can develop software, you are amongst the elite of the population. Okay, it's intellectually it's one of the hardest things that human beings do. I'm fond of noting that in software development, our dumb people are smarter than the dumb people in anybody else's profession. We have the smartest dumb people because the entry level is that high. The people who are not, who are at what we consider to be the lower end of the bell curve from programming, are way above the intellectual capacity of those in other groups. We have the best dumb people. So typically you're dealing with a group of very smart people. And it turns out that when you get a group of very smart people together and you say, you know what, we need 100% statement coverage, and you get a bonus, they will bring that intellectual capacity to bear, not in a malicious way. It turns out software developers are actually quite nice people, in terms of all the sectors of the population. People are generally fairly nice. They don't do things maliciously. So what actually happens is, without meaning to, people will influence, they will gain it unintentionally. They will just make a choice, perhaps to delete that catch block that they weren't entirely sure that they wanted to do because they can't get any coverage on it. So therefore, whoops, there it goes. That little debug method that they snuck in, well, let's put a test in for it. Because now we get 100% statement coverage. That was one that came up here. Or this thing that's really too hard to test, but it returns some non-null result. It's just that we don't really understand the nature of the result. Well, let's just assert that it's not null. There we go, we've got 100% coverage and an assertion. That's the important thing. You can get 100% statement coverage just by running the code. But occasionally do check your tests and make sure they've all got assertions in them. But that point there is that accidentally, without meaning to, you may reward at a lower level a behavior that's not the one that you wanted. So what actually drives people? Well, this study a few years ago, it wasn't specifically programmers, but it was a very simple one. Ask leaders what they think makes employees enthusiastic about work, and they'll tell you in no uncertain terms. In a recent survey, we invited more than 600 managers from dozens of companies to rank the impact on employee motivation, emotion, etc., recognition, incentives, interpersonal support, and so on. Now, importantly, these are knowledge workers. We're not talking about M&M sorters. We are talking about knowledge workers, of which software development is certainly one kind of knowledge work. Okay, what do people think? Recognition for good work is the number one thing. Those managers are unfortunately wrong. This idea of recognition, it's not that it doesn't matter, it's just that it's not the number one thing. Having just completed a multi-year study tracking the day-to-day activities, emotions and motivation levels of hundreds of knowledge workers, we now know the top motivation of performance is, and amazingly, is the fact that those survey participants ranked dead last, it's progress. It is the feeling and experience of progress, that when you go in the morning, when you leave in the evening, you will have experienced progress. Something will have happened. Moving forward in an intellectual or physical way, something will have happened. A problem that you had before is no longer a problem. It has been solved. Even simple things like the class that you had not written is now written. The test that you had not written, now written. The test that was not passing is now passing. All of these are indicators of progress. It's a very simple reward mechanism. It is that feeling of having progressed through something. It turns out that is a really key idea. So let's talk about progress. Let's talk about the burn down. That is an indication of progress. The idea is there's a bunch of stuff that we're going to work through, and there's a period of time. What we would like to see is that over time we work through the stuff. So there's an actual indication of progress. This is great. What we want is some indication. This is the satisfaction you get from a to-do list as you cross things off. Okay? That's why still, even after all these years, I still prefer a physical to-do list because you just can't beat that physical connection to,
It's a big tick.
Yeah, it's a big tick. And there is a great satisfaction in then actually physically getting up and make sure the recycling bin's not too close to your desk. When you walk to that, put it by the coffee machine because you can have the coffee of champions at that point. As you, done. It turns out we're very physical creatures. We are tuned to the physical world. This is unsurprising. And many of these things actually have an effect on how we think. But even intellectually, that sense of progress is such a key idea. So, the burn down chart. There's no mystery, by the way, as to why it's called burn down. People sort of read things in. Jeff Sutherland was a pilot, US Navy, if I remember correctly. He certainly flew on aircraft carriers, which would narrow the options there. US Navy. Turns out that America has the two largest air forces in the world. The US Air Force is the first, the US Navy is the second largest air force on the planet. It's something not quite right with that picture. But he flew phantom jets, and that's what you call the profile as you approach an aircraft carrier. It turns out you don't want to hit the water and you don't want to run off the end. So it's really important to get the right bit. They practice that a lot. And so therefore you concentrate on your burn down. There you go, no mystery. That's why it's called that. There is what some people consider to be an idealised burn down. Now, there is no mystery as to the idea. There is a sense of progress. We started with this stuff to do, and look how we are burning through it. This is our to-do list. We are burning through it. This is time. This is either our sprint burn down, or it is the sprint down of a release, or something like that. So with duration of time, we are burning through it, and then we hit the x-axis, and we're good, we're released, and everybody's happy. But there is a question. That's a big picture, fluffy view. What's the detail? Detail. Amount of work left to do. That's what it should be about. Against time. Problem. What do people actually put? What do people actually put? They put hours against days. This is very common. Not everybody does this, but this is certainly something that has been recommended in a number of blogs, a number of books, and a number of training courses. You will estimate the amount of work you have. You estimate each story. You estimate how much work is involved in terms of hours. In these days we like to try and hold back a bit from that, but hours. There is a problem. Well, there's a couple of problems here. One, quite frankly, you just don't know. I mean, sometimes I can look at something and say, yeah, it's a couple of days. But if I quantify it as 14 hours, that's very different. Turns out you will be measured by the unit that you choose. If I say this task is about a year, or this project, I reckon that's about a year's worth of work. That's actually completely different to saying, you know what, that's 52 weeks of work. About a year sort of says, you know what, it could be 10, it could be 11, it could be 12, 13, 14 months. 52 weeks brooks very little negotiation. 52 weeks is a curiously precise figure. It comes in at two significant figures, which may give you 1 week either way, but that's it. If you say this is going to take hours, you'll be measured on hours. If you say this is about this many weeks, it looks different. Yeah. I'll be with you in 5 minutes. I'll be with you in a bit. I'll be with you in 60 minutes. I'll be there in about an hour. Notice these actually feel differently. The problem is you have too much education. You're too smart. You have years that tells you that 60 minutes is equivalent to an hour. That tells you that there are 5 days in a working week. That tells you the number of weeks in a year, and you readily translate freely between these formats. That's great. That's just not how you actually think. There's multiple thinking systems going on. And it turns out that these they're not all equivalent. So you have a different feeling. When I use a particular unit, it induces a particular feeling. So first of all, this is way too small to be doing software development at. It's like filling out timesheets at quarter-hour level, something crazy like that. So one issue is our choice of units. But nonetheless, there is this other thing that always used to bug me. If you have a numerate degree, I'm afraid I'm going to exclude computer science from this one, because although it does use numbers, it never uses units. If you have a background in some kind of physical engineering, physics, chemistry, any one of these things, one of the things that you'll have drilled into you, it's probably still, right in the back of your skull somewhere. Dimensional analysis, check your units. Check your units. What's the answer? 5. 5 what? 5 kilograms? 5 light years? You don't do anything unless you've got units, and then you work out, light years, that's distance, it's not time. If you're doing hours against days, that's time against time, what are you plotting? What are you plotting? Unfortunately, in most cases, it turns out that we're plotting utilisation, which is probably not what we're meant to do at all. We take the original estimate, let's say we estimated the task 7 hours. I worked 4 hours on it today. I take 7 minus 4, that's 3. I've reduced that number. What I'm going to end up doing is plotting the number of hours I work per day. The burn down is not doing very much here. And it should always go down in a fairly decent way unless you go to a lot of meetings. That's not very helpful. So although it's a visualization, it's not real progress. It's an artificial kind of progress. And leaves you with a nice big surprise at the end of the sprint. Hours of work remaining is what you want. Now that's also very hard. I could have taken a 7-hour task, done 4 hours of work with it, and have 10 hours left. Damn. It's like we're going into reverse. No, we're not going into reverse. We're discovering stuff. This is way more complex than we originally anticipated. But at least that's the thing you should be aspiring to. Time remaining, based, not time, time estimated minus time worked. That's utilization. Time remaining. At this point, we still believe. It's a bit like I live in Bristol, which is 120 miles away from London. How long does it take to drive from Bristol to London? If you want to give me a probability.
4 hours.
4 hours, some days. 2 hours, at the fastest I've ever done it is 1 hour and 45. I will say it was a particular time of night, and I may not have been entirely within the law, but,
Did you get caught?
And this is being recorded, isn't it? I'm not providing any data, I'm not going to tell you what the registration of the vehicle was. But yeah, it's actually taken me once 4 hours. I've taken more than a couple of occasions, it's taken 3.5 hours. The point there is if I originally estimated that 2.25 hours is fairly typical to get to my parents. So if I sort of say, 2.25 hours, so how are you doing? Yeah, well, hour and a half in, we're stuck in a traffic jam, but we'll be there in 45 minutes. What? How can you say that? Well, because the original estimate was 2.25 hours and we've spent 90 minutes already, so therefore there must be 45 minutes left. No, you know what? We may have spent an hour and a half, there could still be an hour and a half to go. You need to, it's not the figure people want to hear, but it becomes important. That's a cue. So this is another thing, is hours is a problem because it attracts people into micromanagement. Okay, it makes people track the wrong thing. Scrum and other agile approaches are supposed to be very light in terms of their management approach. Doesn't mean that necessarily they have no managers, but it means that the management is not at this level. You're not managing the person or the task, you're actually managing clearance around the task and around them. It's a very different kind of thing. And when you use things like hours, it attracts people to the wrong, it rewards the wrong behavior, it encourages the wrong behavior. So again, people are doing the wrong thing, not because they're stupid or evil or anything like that. So, here's a more meaningful one. Items of work complete. No partial credit. If it's not done, it's not done. Don't take credit for it. So in other words, you can end up having worked all of the hours you were sent and actually still not have actually made much progress at all, which is slightly depressing, but there we go. It's slightly real. Okay. Now, I just want to close with a kind of observation about a different visualization. Work completed. If I want to see progress, the other thing I want to do is see how much I have done, not how much I have left to do. Because as anybody who has ever used a to-do list knows, it can be surprisingly full at the end of the day. Fuller than when you started, even though you've done great progress. You need other forms of visualization. Ones that the backlog visualization, burn down, gives you the remaining work, but will unfortunately not look good if you keep having work added, or as you estimate things up. There are more sophisticated approaches, cumulative flow diagrams, which I'm not going to cover here. But I want to talk about a build-up chart, sometimes called a burn-up chart, but speaking as somebody who's very interested in space travel and who has children, the word burn-up doesn't sound like a good thing. Okay. How much have we built? That's a very different thing. Yeah? It speaks to the idea of incremental development. How are we doing? We started with this much. We incremented on it. We should have increments. This is a very important visualization. This is very rewarding. You actually see what's going on. Now, importantly, I've used straight lines here, and lots of books use straight lines. They shouldn't. This is sometimes the right shape. Sometimes you start slowly to build up speed. The less well-known a task is, the more cautiously and knowledge-gatheringly, I'm really sure that that's not an adverb, you should approach it. sometimes what you will do is actually spend time working around a task, not trying to deliver working software, but working knowledge, which means that you may not emphasize the delivery of stories at that point. You'll use a story as as kind of like the backbone on which to discover this knowledge, but you will actually spend time working at what seems like a fairly slow pace. And if you're tracking this on a graph and somebody's expecting a straight line, they will be concerned. So you have to be very careful about visualizing this, which is why I sometimes recommend that people actually put up on a board their sprint objectives in terms of discoveries, or things we need to learn, things we need to find out. Not just stories, don't just track stories. Track unknowns, track risks that you have de-risked. Here is a thing that will harm us if we do not find out about it. Okay? Here is a thing that we do not know the answer to. Put it on the board. Yeah? Because it will give you the sense of real progress. Oh, we've learned about that, we've solved that problem. Okay? Otherwise it has to be something that feels right. Because otherwise this can look concerning. It looks like a low productivity start. We need to speed that up. But actually, we may actually be doing exactly the right thing. We may be gathering knowledge, and the knowledge is what, but we don't visualize the knowledge. I can point to code far more easily than I can point to knowledge. And damn it, code is hard to quantify. Knowledge is even harder. So we need to be sympathetic to that idea of knowledge gathering and knowledge acquisition. Or to put it another way, knowledge gathering and knowledge acquisition are also known as learning. That's what your development process should look like, a learning process. You should be sympathetic to the individuals and interactions. So I will close with this observation. It's actually the title of a talk given by Helen Sharp. She's from the Open University. She gave a talk at the ACCU conference in Oxford a few years ago. It was entitled Software Development, a Social Activity with Technical Practices. She's actually one of the people who's done this ethnography study, ethnographic approach to looking at software teams. And this is the important point. This is your individuals and interactions. That's where it comes in. Yeah, sure, there's a lot of technical stuff. Technical stuff is why a lot of people are motivated to get into it. But if you're going to sustain it for anything beyond a pet project, then software development needs to encompass all of this. Okay, right. We're overdue for coffee, which is actually the other important point I haven't talked about in terms of software development. Thank you very much for your time. I'm around for the next couple of days if you have any questions. See you around.